thanks everybody for joining us. Welcome to the next episode of FinOps on Azure, the podcast where we want to get people to talk about cost management challenges on Azure, to talk about how to tune and optimize the solutions that we build in the cloud. And today we're joined by Gary Hope. Gary's a member of the Cosmos DB team. And I've had a lot of people who, when I speak at events, ask me about how do I run Cosmos DB efficiently on the cloud. Really interesting one. So just a shout out to a fellow podcast, the FinOps guys, who invited me as a guest on their podcast last week. And we had this great conversation about how do you get started with free stuff on Azure. And one of the things that came up in the solution we sort of built in our heads was the fantastic offering for Cosmos DB. You can do a lot of stuff for free, which is a huge benefit. It actually really excited the guys because they come from a more AWS background, and they were quite excited with what you could do with Cosmos. But when we're out at user groups, we often hear people sort of asking lots of questions about how Cosmos is affected at a cost level. So I reached out to the team. Gary very kindly offered to join us today to talk about some of these questions, and hopefully we can start demystifying some of the questions that people are putting out. So thank you, Gary, for joining us. Would you like to tell us a little bit about yourself before we jump in?
Sure. Thank you for the invite, Mike. I'm very happy to be here today. So I'm Gary Hope. I'm a program manager on the Cosmos DB team. I work a lot with the Microsoft success teams. So across the organization, we have our CSU or Microsoft success teams, and they work with customers to help them optimize their environments and get them into that perfect cost optimized state. And we've had a lot of learnings together as a product team and with that success team as well.
Okay. So if we jump into the questions then, Gary, so I think when we were chatting before, one of the first things when people start using Cosmos is there's a few provisioning choices that you have to make, which will influence a number of follow-on factors that relate to how you'll use Cosmos DB. So do you want to talk us through what those provisioning models are and what your first thoughts would be when you're going to start a project with Cosmos DB?
So I think firstly we have these different APIs that we have within our service. I think it's important that we address that right up front. In Cosmos DB we have a set of APIs that are document related, NoSQL APIs. So we have MongoDB, Cosmos DB for MongoDB, and that comes in two flavors. It comes in a provision throughput flavor and vCore kind of CPU provision flavor, and that's an example of the types of models that we have from a provisioning perspective. The choices that you have are firstly going to be around the actual API. Are you looking for Cosmos DB for Postgres? It's a relational model. Are you looking for that document model? It could be Cosmos DB for NoSQL, which is our default primary API. Or are you looking for other types of migration workloads? So things like your examples are the MongoDB that I gave you, or storage. Table storage is another example of a migration workload. We have customers that are on table storage and want to move across. But we have these provision throughput models or RU-based models that allow us to choose between how we provision that resource per container. Cosmos DB's provisioning is at a very granular level. So we do it not at the account or the database level, but actually at the container level. And you choose to provision resources for that specific container in Cosmos DB. And that is typically measured in throughput. And throughput is just a measure of the number of operations and the size or cost of those operations that you can achieve in any 1 second. And that is the typical model. And that's the place where most customers and our kind of field have questions around Cosmos DB cost.
So I guess the question there, Gary, when you talk about that sort of request unit at the container level versus the account level, I guess there's different choices there, isn't it? I know there's a couple of times I've done it at the account level, but then I wonder later, would I be better off having certain tables have higher throughput or other tables where I kind of want to share the throughput? And I guess that would be more at an account level. How would you maybe sort of slice and dice things in the real world? Would you possibly have two separate accounts where you do it different ways in an application if you had a bunch of collections?
So let me kind of just unpack that in a little bit more detail. Cosmos DB, we provision throughput at either the database level or at the container level, or in the case of vCore, we provision it at the account level. So when we're provisioning throughput, it is at the database or container level, but when we're provisioning vCores, it's at that account level.
So I guess in that terminology, the vCore model is a lot more like what people are probably familiar with a SQL Azure database, I guess.
Correct. And that vCore model applies only to specific APIs. So it applies to our MongoDB vCore API, and it applies to our Postgres API.
Got you. Okay, and when you mention that you've got those different APIs available, do you tend to find people build applications that may use more than one of those APIs in the same application?
We do have customers who do that. What we tend to find is that customers choose that API based on where they're coming from primarily, rather than a greenfield choice that they make. So, for instance, our MongoDB customers will typically be customers who are coming from a MongoDB environment and migrating to Cosmos DB for MongoDB. And in that scenario, they'll typically choose the vCore provision throughput, the provisioning model, because over the throughput provisioning model, because they are the most familiar with that and gives them the most flexibility and provides the same characteristics that they would have got in their on-premises or other vCore provision environments.
So I guess that's more of like a comfort thing of that. That's what we were used to on the Mongo side.
Correct.
Same on the Azure side. Okay, I get you. And so I guess the next question would be if I'm speaking to people at these user groups, and sometimes we come across people who've sort of tried Cosmos and then feel it gets expensive, and they don't really understand quite why it's costing them more than what they were expecting. So what are the common things that you find when you speak to people who have that experience?
I think one of the most surprising common scenario is that customers provisioned resources that they don't use. I think that's a very surprising start to this journey. The others are more complicated, but this one is very simple because we provision resources at such a granular level. When you create containers to hold data, and that data is relevant for when you create it, customers often forget about the fact that they have this resource. It is provisioned with the throughputs associated with it, and it sticks around for a while. And those small provision throughputs add up to a significant amount of cost for those customers. So step one for customers, I always recommend they have a look at their environment and understand, do they need those resources that they provision? Things like development environments and testing environments often are resources that are provisioned temporarily but stick around for a long time. So that's a super easy, quick win to get to your.
It's a really common one actually, Gary, across the board with Azure. The more of these kind of discussions we have, the more customers we find that just have got waste they forgot about, and cleaning up things you don't use anymore actually has significant cost savings for people, or even investing in the automation so you can rebuild it when you need it, kind of thing, is a good one as well.
Right. We see it with like VMs as well, like
VMs,
and storage too. It's easy to copy stuff and leave stuff lying around. But Cosmos DB, that's also very true. Let's talk a little bit about the other things that contribute to cost. We've spoken about the APIs and the fact that we have this RU-based provisioning model or a vCore provisioning model. Then for the remainder of the conversation, let's stick to the RU-based model. Within that RU-based model, we also have provisioning modes that you can choose. We have a serverless mode, so you can be billed for a request unit, and let's kind of clarify a little bit about what that request unit is. For every operation that you perform on Cosmos DB, we attach a charge associated with that. It's essentially the currency that we use to measure every operation in Cosmos DB. So if you're doing a 1 kilobyte read of a document in our NoSQL API, that will cost you 1 RU. And that applies to every type of operation, whether it's a query or an insert or an upsert operation. Those are all built in those request units. In serverless, what we do is we charge you for the actual operation. So you can buy essentially 1 million request units at a couple of cents for those request units, and you consume down from that amount of request units that you've essentially purchased at a rate. And then in the provision throughput model, what you do is you provision an amount of throughput, which is a number of request units per second, and you consume down on against that on a per second basis. So you'll have on a per second basis the number of request units that you've used. If you use up all of your provision throughput, you will be rate limited, so you'll be limited to that amount of provision throughput, and you'll be charged for that provision throughput for every hour of the day that you've chosen to provision that. And that's called manual provision throughput. And then we have auto-scale provision throughput, where you choose the maximum that you want on a per request unit basis or throughput basis. It is slightly more expensive. It is like 1.5 times the cost of manual provision throughput, but you can scale down to 10% of that automatically on an hour-by-hour basis. So if you only used it for 6 hours a day, those 6 hours will be billed at that percentage that you use for those 6 hours. But the remainder will be billed at that minimum 10% of what your maximum was.
So with autoscale, Gary, I guess a use case that could really apply to was if I've got an application that's mainly used during the business day, it'll automatically scale up as more users are using my application. But then after hours, I guess it will just automatically scale down as the usage drops off. And that would be a great way of optimizing my cost in that scenario. Is that kind of a good assumption there?
That's a perfect assumption. So a lot of workloads are very cyclical on a day-to-day, week-to-week, month-to-month basis. And autoscale provides you the ability to choose the maximum amount of throughput that you need. And as I said, it'll scale all the way down to 10% of that. And it'll just automatically on an hour-by-hour basis as to what throughput you're billed for each of those hours in the month. That's great for production workload and useful for scenarios where you may be having a lot of Q&A or testing happening. But there are also other scenarios where serverless may be a better choice for things like development. If you're doing functional development testing, that serverless model, because you do so few operations to do some functional testing, it may be the most cost-effective.
I guess from the developer or the application perspective, using the SDK, you don't really care what mode's provisioned behind the scenes. The application just calls the API.
Correct. The SDK and the APIs are exactly the same, whether you use that serverless mode or that provision throughput mode.
So when I have that auto scaling feature enabled, and does my application have any service interruption or awareness that the database is scaling up or down, or is that very transparent?
So that's one of the unique features of Cosmos DB's autoscale, is that scale up and scale down operations are instantaneous. You are billed for the utilization for the hour, but it is at the time of scale up or scale down an instantaneous operation. So you can think about it as more of a billing model than it is in terms of a resource provisioning model, where we actually have to do some work to actually get that resource allocated to you. So there's no delay in getting access to.
So I would assume that's probably one of the features people maybe don't know enough about, I guess, in some ways, that they haven't realized, because that, when you think about comparison with a traditional database like a SQL database, that kind of feature is just not really in the game for you, is it? And that's a huge benefit over Cosmos.
Correct.
So when it comes to kind of factors that affect the cost on a Cosmos DB, what do you think are the, say, maybe top 5 most important things that people should think about what you could be doing that affects the cost? I mean, obviously we've just talked about the, kind of the provisioned model, the RU model, the types of API that you might use. So let's assume I've picked that bit. What other kind of things can come into play?
So I think starting at the top there, that getting rid of unused and unneeded resources is probably the number one easiest win. And then choosing that model appropriately for your workload. So in most cases, customers should choose autoscale, and that autoscale will provide you with the flexibility of providing you with the resources that you need when you need them, and the cost optimization when you are not needing those resources. It will dynamically do that for you. And then making that choice appropriately between that and serverless, maybe for some development workloads, or manual where you have continuous workload requirements. So some examples of that are things like IoT workloads, where they're submitting a message every 5 seconds from 1 million devices. It's continuously arriving every 5 seconds. You know what your throughput is. You can optimize it so that you've allocated exactly the right amount of resources. And in those situations, although they're a lot less common, manual can be a more optimal approach to that.
Yeah, I get you. So what about things like, let's say I've chosen the sort of auto scale model. I've picked the kind of the document API. I've started building my application. Is there things about how I may model my data or how I may query my data that can come into play at this point?
So I think we're still on that. We're like number 2 on that list of.
Oh, right. Things. Yeah, keep going. Yeah, sorry. I thought you...
So like the third one would probably, actually, before we move off the provision throughput model, order scale specifically, we also have a new dynamic order scale provisioning mode that we've recently announced. If you're provisioning a new Cosmos DB account, you can elect to use that since November last year, whereby we will scale the Cosmos DB account not across all partitions. So Cosmos DB is a partition database, but scale each partition independently and bill for each partition independently, and each region independently. So you could have multiple regions in your Cosmos DB account, and each of those regions could be utilized differently depending on your workload. And that gives you an additional level of optimization on top of the traditional order scale that we've had for a long time now. But going one level lower than that, we get to that partitioning challenge. So Cosmos DB is a distributed database. It does have this concept of partitioning, where we choose a specific partition key in our data set to help direct that data to a specific set of underlying resources for that. And those partitions, or physical partitions specifically, are the actual resources that back that Cosmos DB account. If you choose a partition key poorly, what we'll end up doing is directing all the workload or all the data to a subset or even just one of those physical partitions, and the others will be left unused or partially unused. And that will result in costs associated with those unused partitions, adding to your cost, but not bringing you significant benefit from a storage or performance perspective.
Yeah.
That order scale, that dynamic order scale I was talking about, because we now bill per partition, eliminates some of that. But customers still need to be very aware of making that partition choice appropriately and revisiting that partition choice when needed. So that's the third thing on the list. And then the other one, in addition to just unused resources, is a large amount of data gets put into Cosmos DB that is unused and drives the cost, because one of the things that drive the number of partitions that we have in a Cosmos DB database is the amount of storage that we provision per partition. And if you just store a lot of data in there that's unused, you end up with these large numbers of partitions, and those contribute to additional cost. And then the last one on that list in terms of the actual database operations themselves, I would say, is choosing the appropriate indexing choices. Cosmos DB is like any other database, has an indexing policy that we apply to that container, and that indexing policy tells Cosmos DB what properties of those containers to index, or of the documents within those containers to index, and those choices can also contribute to cost. By default, Cosmos DB actually indexes every property of every document. So if you have a large document with a large number of properties, that cost of doing that right into that database is going to be high by default. It'll optimize for your queries, but it'll also be high by default. And then we have the choice of composite indexes as well, where you want to be able to choose which properties you want to combine together to solve specific query problems. And we find that those are underutilized and again increase the cost where customers aren't choosing the appropriate indexing approach.
So there's quite a lot of factors there, really. Do you mind if I sort of dig into a couple of those?
Absolutely, dig in.
So, because I made a few notes when you were going through them, actually, because the good follow-on questions, I think. So, partition key, I find, is always a really interesting one. Sometimes I feel like I struggle a little bit to choose a good partition key. I'm sure other people probably have the same challenge. So I guess what I sometimes feel is that either I choose a partition key that's almost going to be the unique key, or I choose a partition key that's so general it would never really segregate any data. Can you maybe give me an example of, like, just maybe like an order, for example? How would you see a good example of a partition key from something like a typical order people might have being saved in Cosmos?
So what we're wanting to do with partitioning is to distribute our data across the available partitions as best as possible, to distribute the workload associated with that data across those partitions as best as possible, and ensure that any one operation touches the lowest number of partitions, because even if the data doesn't exist in that partition, when I submit a query that needs to go and touch every partition, there's some cost associated with evaluating that query that happens at the partition level. So those are the primary things for us to think about. How do I get the data well distributed? How do I get my operations well distributed? And how do I make sure that those operations target a specific subset of partitions in most of the scenarios? Now, that's never going to be a perfect reality. I'm never going to be able to only target a single partition for every query, but I want to optimize that partition key choice so that I do that. And then lastly, the other factor to consider when you making these partition key choices is that our transaction boundaries for cross-document operations is at that partition key level, at the logical partition key level. So you're going to want to make sure that for documents that you want to include in the same transactional operation, that they land on the same partition. And there are limits associated with those physical partitions that exist in the background. We can provision, as I mentioned, one of the things that drive that is the storage. So if I have a partition, it can hold up to a maximum of 50 gigs of data. And if I have a single partition, physical partition, it can hold a maximum of 10,000 request units a second. If I go above that 10,000, it's automatically going to split into two. If I go above that 50 gigs of data, it's going to automatically split into two and drive that partition count up. So those are the things that drive the partition count. So
if we just play that order scenario back as an example, just to help people kind of get their head around that. So if I said, right, I'll save an order and I'll choose the partition key to be a customer ID, then I'd effectively end up with one partition per customer.
Correct.
And then I guess if I could do a query that is, give me all the orders for this customer, that would, theoretically, that would probably target just one set of resources under the hood.
Correct.
That query. But then if I wanted a query, give me all the orders we received yesterday, that obviously is going to cover multiple customers, and it would hit multiple kind of partitions, I guess.
Correct. That's exactly how to think about it. In that order scenario, customer is a good choice for queries, because if you think about it, the majority of queries in a retail system are going to be about that customer. They're going to be looking for the orders for that customer. Customer is going to be the primary thing.
And I guess when you come to that other query about give me all the orders yesterday, that could be the kind of thing where the Cosmos DB synapse link type stuff comes into play, I guess, maybe.
Before we get to that, I think that what you want to think about is that behavior that you get in that scenario, because they are few, is actually the behavior that you want. You want that result back as quickly as you can get it. And if I had a pile of money and I wanted to count that pile of money, I would be better off dividing it up amongst 10 people, have each person count their pile of money, tell me the results, add them together. And that's more or less what's going to happen in that case where you say, give me the sales for all customers across the time yesterday. I'll dish out that query to all of the partitions. They'll each do their own little bit of work. They'll give me the result back. And that's actually the behavior that I want. The fact that it's going to be more expensive from a request unit perspective is something I can tolerate if it's an infrequent query. If it was something that was the majority of my query set, then I think we want to think about doing things differently. And I think you alluded to our Synapse Link capability, and that allows us to have what we call an analytical store in addition to this transactional store that we have in Cosmos DB. That analytical store is essentially optimized for those large scan-heavy queries. It is a columnar store, and it is exposed through Synapse as both T-SQL as part of the T-SQL serverless endpoint and as part of the Spark endpoints in Synapse. So now I can run those scan-heavy queries that maybe I want to do a weekly analysis of what products were sold. It's going to need to go and trawl through all the data, the sales data for all of my customers for the whole week. That's much better done in an analytical product like Synapse. And we also have mirroring now enabled for Fabric as well. So you can do that both in Synapse and in Fabric.
So that really helps me actually understand that. I think that was a good way you explained that off the back of the example there. So hopefully that helps other people as well. So one of the other questions I had from your list of top things, Ollie, you mentioned about the indexing of properties and how every property gets indexed by default. So just defining what's meant by a property. Is that like on a JSON object saved, each field would be a property?
Correct.
Correct. What about things like subfields in a child object? Would they get indexed as well?
They all get indexed. Every property in every document or sub-document or array within that JSON document. So when we're talking about these document-oriented databases, we're talking about a JSON document, and they would be indexed individually as properties, whether they're part of the base document or part of any of those embedded documents or arrays that existed within that JSON.
Yeah, I get you. And I guess where you're saying you would sort of configure your indexes, that would be where you want to take away indexes because you want to minimize what gets indexed as opposed to add them because it does everything by default.
Correct. Or you want to add indexes that aren't just single property indexes. In Cosmos DB, we have this ability to create composite indexes, and that means that you can combine properties to solve the types of multi-filter queries that you might have. So you might say, I want to filter by customer and by product, and that's the typical query I want to do. Now, in that scenario, we have those where clauses that have both of those properties with values. I'd want to put that into one index, then I can use that one index to go and
so that would just be a way of lowering the. So if we go back to that thing you were saying before about the request unit charge for a query, the exact same query with a better index has a lower charge, which means your provisioned RU lasts longer, kind of thing.
Correct. Yeah. So I think in a traditional database world, often we measure that cost of the operation that's poorly indexed by how long it takes. In the Cosmos DB world, it can also be directly measured by that request unit charge per operation. So a well-indexed query will be have a lower charge as well as being fast answer.
Yeah. So one of the things you mentioned, Gary, was about cleaning up not just old resources but cleaning up data. So how would I be doing that in an application if I'm saving documents? What processes do people typically use?
So one of the nice things we have in Cosmos DB is a TTL. You can specify how long a document lives in Cosmos DB, and Cosmos DB automatically does that cleanup in the background for you. So when you create that document, you could say, maybe our invoice, in the scenario you're talking about, our invoice retention is 3 years. I could set that value to be 3 years right up front. And when that document is no longer relevant, it'll automatically get cleaned up. I don't have to have a process that goes through and cleans up that data for me. So that's a great feature that a lot of customers utilize to do that. And you can set it as a default, or you can override it at the document level as well. So there's a lot of flexibility. It's not a constraint for a lot of designs.
Do you think Cosmos will ever have something similar to storage accounts, where you have the concept of like hot and cool and archive kind of objects? Or
it is something that we do get a lot of requests from customers. I want to be able to have the storage that is not accessed often, but doesn't directly contribute to my Cosmos DB costs on a day-to-day basis in the same way that hot storage costs would be. All of our storage in Cosmos DB is backed by SSD, so it's intrinsically more expensive than a spinning disk or cheaper types of storage. So it's something that we're definitely working on in the longer term within our product roadmap. I don't have any timelines or commitments to make now, but it is a request that we've heard and we are working to address.
Difficult problem to solve, I guess, as well, isn't it? So I know there's a feature called change tracking in Cosmos DB. I guess that notification, do you see people using that kind of feature to help them optimize costs for Cosmos in any way?
So change feed is a very useful feature, and I think that's the feature you're referring to. It is essentially an ordered list of the operations that are in my database, and it allows me to access those operations in the order in which they occurred, or the documents associated with the operations in the order in which they occurred. And it's very useful for implementing application patterns. So one of the application patterns could be to move data from a provision container into another provision container that is less resources allocated to it for my historic data, and kind of achieve some of that tiering approach you referred to. That is one of the ways that we can do that with that change feed process. We also have, and as I mentioned it today, change feed is based on the ordered list of the documents that are already there. It doesn't track intermediate states. So if I updated a document twice and now I go and read that change feed, its position in that list, and that ordered list, would be the latest operation state. Or if I remove that document from that container, it won't show up in that change feed. We have a new feature that is going to allow you to see both those intermediate states and those deleted documents as well. So that's something that's coming.
So I think one of the patterns that I saw a project implement a while ago was they were doing some caching. So I think if you imagine a story, we've got an API we call, it's using a Redis cache, but if it's not in the cache, it's querying from DocDB. Mm-hmm. And then when they do, from Cosmos DB, brains using the old name there. So when they do an update, they'll be using the change feed to kind of update the cache. And is that something that you see quite often, or with that caching approach, is Cosmos giving me stuff out the box that'll kind of negate the need for caching potentially? Or
so Cosmos DB has an integrated cache capability, so you can enable that directly on your Cosmos DB account, which has the advantage of being able to use the same SDKs that you would use against your existing Cosmos DB interaction, but now just get that cached version of either a query or a point operation reading or writing a document. And that integrated cache can just be enabled through a couple of clicks in the portal or an ARM deployment or whatever that approach is that you have to do in your deployments. The pattern that you refer to in terms of using change feed to inform cache is not a typical thing that we see most customers use operation that then updates the cache based on the actual operation. But it is definitely a pattern that could be adopted. There's nothing against adopting that pattern. It's just
so that's quite cool
in the customers that I've seen.
Yeah, it's quite cool, that integrated cache thing, because that really kind of potentially removes the need for that pattern altogether, doesn't it? If you can just configure that on the Cosmos DB. So
correct, and the ease of adoption is one of the things that is very useful there. In that I'm not changing my application. I'm just saying use the cache, configure it in this way, and now my application will be able to take advantage of cache.
Yeah, I get you. So coming back to some of the other questions, and so what about things like you mentioned earlier about the size of the object that you save in a collection can significantly impact the costs. So I guess, is there things like just save the properties that you really want to be in Cosmos DB, or is that a recommendation that you guys would see, or do you find customers often just save an entire huge object but only really need certain parts of it in Cosmos?
Cosmos DB, remember we spoke about those operation costs that are measured in request units. The document size contributes to that document cost. One of the things is to think about the operations that you need to perform against those documents. You may want to persist a large amount of data that is used rarely in a different document than you do to the data that is used continuously, to avoid that cost of every operation carrying that cost of that large amount of documents or large documents. And we generally recommend that customers use smaller documents in Cosmos DB. So it goes back to that modeling question around how do I appropriately model my data so that those operations have the appropriate cost associated with them for my application function.
So if we take an example for that one, I think what you're saying is something like, if I had an order, I saved 100 orders for the customer, I may save 2 objects. One would be the entire order, which might be quite big, but then I might also save a metadata object for each order, which only has maybe like the half a dozen properties that I would search on. So if I was searching for an order, I might just say, do a query of those metadata objects for that customer, get a list of the orders, pick the one I want, and then do a primary key query to get the entire order object, which has more in it.
That could be a pattern. It's unlikely to apply to an object like orders, because an order, even though it may feel big and that it's composed of multiple, it has an array in it and it has all the order items in it. The actual order document size is typically quite small as well. It's in the couple of K typically, if I imagined an order typical of most ordering systems. It's that scenario as it applies to larger documents. When we get into tens or hundreds of Ks of data in a document, Cosmos DB NoSQL API, for example, supports up to 2 megs of data in a document. So it's those larger documents that you'd probably want to think about breaking up. Orders maybe not a great example, but the need to break
principle's
it up.
The same kind of thing.
Yeah. I mean, the things you really want to try and avoid is like embedding images or binary data in a document that is not used regularly or as part of every operation, and is large. In that scenario, you're probably better off using Cosmos DB as the indexing store, where you do your queries and you identify the data that you want, and then you go and fetch that binary data from Azure Blob or other more cost-effective ways of storing that data.
Yeah, I get you. So Gary, I know we're kind of not far off time. A really important question I think people would probably want to ask about is tooling that you think people should look at to, obviously things like these query costs and operation costs. What's the best way people can kind of do analysis on their application usage to work out where can they tune certain things to benefit them from a cost perspective? Do you have any recommended tools that you would get people to point to?
I think the first and primary place people should look to is our portal. Within our portal, we expose a bunch of metrics around each of the containers that you provision there. And you can get a very good understanding of these things like the request unit charge on aggregate through those metrics, like how many request units are being consumed, what are the types of operations that are contributing to those, how are those operations distributed over time, remembering that we bill for the maximum amount of throughput that you consume in an hour. So the portal metrics is the first place. And then log analytics provides you with very detailed data if you want to be able to do analysis right down to the operation level, like what is this part of my application contributing in terms of resource requirements, what do the patterns look like there, the log analytics capability.
So when you say log analytics, do you mean that on the Cosmos side you've configured diagnostic settings?
Correct.
That's logging, is it? Because I guess you could also have that on the client side if your web apps talking to App Insights. I guess you may get a little bit there as well.
Right, and you can correlate those two if you're using the logging into a standard shared store at the back end. So it's useful to have that level of detail. It's not something I would enable by default. That does actually carry a cost associated with it. If you turn it on and leave it on, it can add to a significant cost for your Cosmos DB account. But if you're attempting to diagnose and understand stuff, it's a very useful way to get into the detail. Those are probably the kind of two easiest ways for customers to start looking at that.
That's really great. I think that's maybe one people maybe don't realize by default that the two recommendations: one, it's there, and two, turn it off when you need it. On when you need it and off when you don't. Because I think a lot of people sometimes turn those logs on and forget them, and actually, like you say, you could incur quite a significant cost on there. I think so. Just last question, Gary, for today: is there any bits or any messages you'd like to get across to our audience of tips or things that you think they should look at based on where the product team is now, or anything you think they should look out for over the coming months?
I think one of the things that I think customers who've looked at it in the past probably are not aware is the amount of effort that we've put into features like order scale, or dynamic order scale per partition per region. Have a look at those features, see how they impact you and take advantage of them. Just switching from manual to order scale is probably a very easy click stop for customers. Deleting the resources they don't need, very easy way for customers to optimize their cost. Cosmos DB, if you design it appropriately, for a lot of workloads will actually be the cheapest database that you can provision. It is when we don't take those cost considerations into account and we poorly configure our Cosmos DB deployments that we end up in those scenarios where it does cost us a lot of money. And if we end up in production in those scenarios, it can be a very costly adjustment to get back to a cost optimized place. So taking some of those considerations right up front: how do I make the appropriate partition key choices? How do I choose that resource provisioning mode right up front appropriately for the workloads and the characteristics I want from my workload will lead to highly cost-effective Cosmos DB deployment.
Yeah, I think your sort of statement there at the start of answering that question is exactly why we wanted to have this podcast today, was to sort of help get people thinking about the fact that actually if you do this right, it is the best choice. And usually if it's not working for you, you've usually kind of gone off the road a little bit some time ago and not really realized it. I guess one question maybe from what you said, let's say if I made a bad choice on things like the provisioning model of the database, is it something that's easy for me to change later, or would I usually have to set up a new Cosmos account to be on the other model kind of thing, if that was the...
So there are some things that are easy. I think that manual to order scale or order scale to manual switch is a very easy switch. It's like literally go in the portal and hit the button and you're in the right mode. Scaling your resources up and down is a relatively easy mechanism if you understand that when you scale up, You can impact the number of partitions that you have underneath it. We touched on that very briefly. So don't overscale your Cosmos DB account and then want to scale down. But those are real easy levers to change. Things like partition key choices are more tricky because they require that you reconfigure your account. There's no way to dynamically change a partition key within a Cosmos DB container. But we do offer tools now to help you do that. So we give you the ability to, in the portal, automatically copy data from one container to another. So if you have a container that has got a poor partition key choice, you can create a new container with the correct partition key choice, use the in-portal copy to copy that data into that new container, and then switch your app. You still need to do that work of switching your app over. So it varies on that. Indexing is easy because it is something that you can do dynamically and in place to do that. It requires more analysis to understand how to optimize my indexes. And we have indexing advice in our index advisor capabilities. So people who are wanting to do that do have some input into how to do that optimization. But that choice is actually relatively easy once you understand.
Yeah. So I think, Gary, we're just about at time there. Thank you so much for joining us today. I really enjoyed that conversation. Actually, it really sort of makes me think about a lot of things. I hope I asked you some good questions that were interesting for both yourself and the audience. I think we talked about that you might be interested in coming back at some point to talk about some of the other models for Cosmos DB. So hopefully, if people enjoy listening to today's episode, if people ping questions, I can keep hold of them for a future podcast. And I think, once again, thanks, Gary. Your team are doing a really cracking job, and we really appreciate you joining us on today's podcast. Is there any last things you would like to point people to that the team are doing before we wrap up?
I think check out our documentation. We try to do a really good job of documenting a lot of these capabilities, features, and the benefits. So if you're looking at doing cost optimization, go and have a look at the Cosmos DB documentation. Reach out to your account team. As I mentioned, I work with the Microsoft success teams across the org, and they're deeply involved and deeply invested into putting customers in the right place. So reach out to your account team and express any concern that you may have. They have or are the right resources to help you solve those problems. I think those would be the key takeaways from an action point of view.
Perfect. Thank you very much again. Have a great week, everybody, and thank you for listening to this episode of FinOps on Azure.
Thank you, Mike, and thanks for inviting me.